Welcome! In this lesson, we will explore permutation tests for hypothesis testing. Permutation tests are a flexible, non-parametric approach for comparing groups when you are unsure about the underlying distribution. We will start by understanding the basics of probability and statistics. Then we will learn about descriptive statistics and hypothesis testing. We will use Python and real datasets to practice each step. By the end, you will be ready to apply permutation tests to your own data. Permutations tests for hypothesis testing. Welcome! In this lesson, we will explore permutation tests for hypothesis testing. Permutation tests are a flexible, non-parametric approach for comparing groups when you are unsure about the underlying distribution. We will start by understanding the basics of probability and statistics. Then we will learn about descriptive statistics and hypothesis testing. We will use Python and real datasets to practice each step. By the end, you will be ready to apply permutation tests to your own data. Running the cell now. Let us begin. Now, we will import libraries for data analysis and plotting. We are bringing in libraries to help us with data analysis and visualization. This line turns off unnecessary warning messages, so our outputs look cleaner. NumPy helps us work with arrays and random numbers. Pandas lets us handle data tables easily. Seaborn gives us nice-looking plots, and Matplotlib lets us make charts. Running the cell now. If you see no errors, these libraries are ready to use. Let us load a dataset to practice on. These comments show we are getting our data ready. We chose the tips dataset, which records restaurant bills and tips. This loads the dataset into a table. Here we ask Python how many rows and columns are in the data. Now we look at the first few rows, like peeking at the top of a spreadsheet. Running the cell now. Practice prompt, try loading other datasets built into Seaborn, like Iris or Titanic. What information do they have? Basics of probability. Probability tells us how likely an event is to happen. The value is always between 0 and 1. Example. Flipping a fair coin, probability of getting heads is 0.5, or 50%. Running the cell now. Let us try simulating a coin flip 10 times using NumPy. The comments explain that we are flipping a coin 10 times. Seeding the random number generator makes our results repeatable. Here, we randomly pick heads or tails, 10 times. We print out the list of results for each flip. This counts how many times heads appeared. Finally, we print out the number of heads we got. Running the cell now. Can you change the size to 20 and see what happens? Now let us calculate the observed probability from the simulation. We will calculate how likely we got heads by dividing the count of heads by the total flips. This computes the probability. Let us print the simulated value. Running the cell now. Does the estimated probability match what we expect for a fair coin? Descriptive statistics overview. Descriptive statistics help us understand data quickly. Measures like the mean, or average, and the median show us where the center of the data is. Example, what is the average tip amount in our dataset? Running the cell now. Let us find the mean and median tip from our tips data. We are going to use the tip column. Calculating the mean, or average, tip value. Now calculating the median, which is the middle tip value. Printing the mean tip amount. Printing the median tip amount. Running the cell now. Which measure do you think is more helpful for this dataset? Why might they be different? Next, we will check if our data has missing values, which can affect our analysis. We are looking for missing or blank values in our table. This counts missing entries column by column. Printing a note telling us what the numbers mean. Showing the count of missing items for each column. Running the cell now. Are any columns missing a lot of values? If needed, we can remove rows that have missing information. This shows how to remove rows that have any missing values. We store the result in a new table. Let us print how many rows and columns are left after cleaning. Running the cell now. For real projects, think about whether to remove or fill in gaps. What is a permutation test? A permutation test helps us compare groups by shuffling data many times. If two groups are truly similar, randomly mixing them should not change the average difference much. Permutation tests do not require normal data or equal group sizes. Running the cell now. Let us see if men and women tip differently using a box plot. We are making a picture called a box plot to compare tips given by each gender. This line sets up the two groups, male and female. We add a title to the chart. Now we show the plot on the screen. Running the cell now. What do you notice about the centers and spreads of each group? Let us write out our hypotheses clearly. This helps us stay focused. We state what we believe if there is no difference between genders. Now we state what we want to test, that the averages are not equal. Running the cell now. Practice, try making your own hypotheses using a different column, like smoker versus non-smoker. Now we compute the observed difference in average tip amounts between males and females. We find the average tip for men. We find the average tip for women. Subtract the two to get the difference. We print out this observed difference so we can compare it later. Running the cell now. Is the value positive or negative? What could that suggest about tipping? Let us perform a permutation test by shuffling group labels many times. We set how many shuffles to run, here 1000. This gets the tip values we are going to mix up. We also fetch the gender labels. We will store the results of each shuffle in a list. We loop over the number of shuffles. Each time, we mix the group labels randomly. Now, we pretend this shuffled group is male and calculate the mean. We do the same for the shuffled female group. Store the difference for this shuffle. Convert our list of differences into a numpy array for accuracy. Running the cell now. Try increasing n_permutations to 5000 to see if results change. Let us visualize our permutation test results. Plot a histogram of all the differences from our permuted datasets. Draw a line to show where the real observed difference sits. Add a label for the horizontal axis. Add a label for the vertical axis. Give our plot a clear title. Show any plot labels, such as for the observed difference. Lastly, we display the plot. Running the cell now. If the red line is far from most results, our difference might be important. Now, we want to know the probability of seeing a difference as big as ours. Here, we compute the p-value. It tells us how surprising our observed difference is. Count the times where shuffled differences are at least as extreme as what we saw. Print the p-value for our permutation test. Running the cell now. A low p-value means the observed difference is rare if the groups are actually the same. Interpreting results. If the p-value is below your threshold, often 0.05, you can reject the null hypothesis. Permutation tests provide a way to assess significance without strict requirements about the data. Running the cell now. Practice prompt. Try the same permutation test using different columns or groupings in the tips dataset. Let us try comparing tips given by smokers versus non-smokers. Calculate the average tip for smokers. Now, get the average tip for non-smokers. Find the difference between these two groups. Print out the results so we can see the difference. Running the cell now. How does this result compare to the gender example? Here is a small project for you to try. Mini project: simulate your own permutation experiment. 1. Choose two groups in the tips data. For example, lunch versus dinner. 2. Compute the observed mean tip difference. 3. Shuffle the group labels and store the mean differences. 4. Visualize results and calculate your own p-value. Share what you learned in the comments. Running the cell now. If you want, pause here and try the steps on your own data. Recap. Permutation tests help compare groups even with unusual data. You learn to write and run your own in Python. Visualization and p-values help you decide if a difference is meaningful. Thanks for learning with us today. Running the cell now. What else would you like to learn about probability and statistics in Python? Comment below. What to try next? Practice on the Titanic dataset. Does class or gender change survival rates? Try more advanced tests, like comparing several groups. See how permutation tests connect with bootstrapping. If you found this helpful, please like and subscribe for more tutorials. Running the cell now. Thank you for joining this lesson. See you in the next video.